Ew. Ever wonder why a vehicle make a weird sound every time they pass by you? Let me give you this little scenario. Two people are remotely standing beside the road. A car is moving towards them, and at a certain point having the same amount of distances from the car, they will hear the sound produced by the car. Do you think person A and person C will hear the same amount of sound? However, person A says, "That car was loud." And person C replied, "That car sounded just fine to me." So, how's that possible? But what sound really did the car produce? A loud sound according to person A, a fine sound heard by person C. Or how about the sound heard by the driver, or person B?
Sound is a wave. Waves from a moving source that bunch up in front and wiggle at the back. So for our case, person A should hear a bunch of sound with high pitch, person B should hear the real sound made inside the car, and person C should hear a loose sound with low pitch. Thus, we conjecture that the car is making all three sounds at the same time, each sound relative to one observer. This is what we call the Doppler effect.
The Doppler effect describes the change in the observed frequency of a wave when there is a relative motion between the observer and the wave source. To really understand the principle of the Doppler effect, we will prove it by an experiment using a sound wave. We will need three devices to perform this experiment. One phone will be used as a sound source producing 1000 Hz. One phone will act as data receiver which has installed the Phyphox application, and one phone will act as the video recorder of the entire experiment. A phone hanging on a pendulum acting as the source will have two sets of strings, 100 cm and 50 cm.
To start, we hang the sound source that produces 1000 Hz. Then we stand the data receiver at one side of the pendulum. From that point where the data receiver is, we mark 5 points. Further, the data receiver will absorb the frequency produced by the source.
We took a video of the whole experiment and take note of the distances below to know the change in frequency. We slowed the video and recorded the time where the sound source is at the certain mark. To know the exact time, we divide the recorded time in slow motion by 8 and we looked for it at the Phyphox received data.
After doing the experiment, the following data were gathered.
Based on the data, we observe that as the length of the string decreases, the velocity and the frequency increases. Thus, the length of the string is inversely proportional to the velocity, and the velocity is directly proportional on the frequency.
The gathered data shows that if the wave source is moving towards the observer, the frequency increases. And if the wave source is moving away from the observer, the frequency decreases. Now, we can conclude that the direction of the wave source is relative to the absorbed frequency of the observer, thus proving the Doppler effect.
This is the mind-blowing idea of the Doppler effect. Observer's perspective is always relative to its reference frame. Now we can conclude that all three observers has a valid point.
Now, before you argue with someone, try to consider your shoes on their reference frame.